All right, in this example, we're going to go ahead and do a little Excel project just to show you how something works here. So for instance, this is going to accompany example 2 from our notes. So example 2, we were to estimate the square root of 5 using Newton's method. So that's exactly what we're going to do. So to do this, I'm going to make a column called n. I'm going to start with 0, and then I'm just going to want to populate this 1, 2, 3, so on and so forth. So we can do a formula. I hit equals to start formula, and then I can use any of these. I can then move or type in manually any cell, and it will use the value in that cell. So I'm going to say take the value from cell A2 and add 1 to it. So 0 plus 1 is 1. And then I can take this little box, the little box there, the lower right-hand corner. I can grab that. See how my cursor changes to a plus, to a little black plus sign? I can grab that and drag that formula down, and then what it's going to do is it's going to duplicate that formula, but it's going to do it in a way that's consistent. If you look up here and you see the formula actually changes. So this is saying take the value from A3 and add 1. Take the value from A4 and add 1. A5, add 1, so on and so forth, so that this just automatically generates a whole list. Let's take this to 20 to get 20 here. So in this column, I'm going to make this the xn column. So this is my, so the value here would be my initial guess, this one right here. So if we do it exactly as I did it in the video for example 2, I use for my initial guess 2. So this is the value that you are going to have to type in yourself. Now over here we're going to have, let's go ahead and get our function value. So f of our x sub n value. And let's get the derivative f prime of our x sub n value. Because remember, for Newton's formula, Newton's method, the formula for it is the n plus 1 x value is the x sub nth x value minus, we're going to take our function at that current x value divided by the derivative at that current x value. So we need to know what the function is at x sub n and the derivative at x sub n. Using those two pieces of information along with what the x sub n value is, we can then get the next one, the n plus 1. So here, for us, our function for this, our function was f of x equals x squared minus 5. So I'm going to treat this as my current x. So equals, to start a formula, I'm going to say x squared, which is going to be this cell, that's the current x value, squared minus 5. And you can see 2 squared is 4, 4 minus 1, or sorry, excuse me, 4 minus 5 is negative 1. I just noticed that I have an error here. This should be squared minus 5. Not that this matters. We're not using this at all, but just for consistency's sake, I wanted to correct that. So now here we need the derivative. So what's the derivative? F prime of x is 2x. So I'm going to say equals the value in B2 times 2. Or if you want to do it in the order, 2x, 2 times our x value. Doesn't matter. Multiplication is commutative. So here we go. So now what I can do is, in this column, in this next cell, I'm going to put the formula that we had right here. So I'm going to take our previous x value, subtract the function value divided by the value of the derivative. And then if you remember from our video, we did get 2.25. So now what I'm going to do is I'm going to drag this column all the way down to fill. It's going to give us errors because there's no value here. in either of these two columns. And it's saying division by 0 because we're supposed to divide by the value in D3, but if you go to D3, there is no value, so it assumes 0, so it is dividing by 0 on all of these. But that's okay. Just go ahead and drag this down, and go ahead and drag this down, and then everything should not give us any issues. But what you can see here is we get the first iteration, we get 2.25. The next iteration, 2.236111. And then 2.236068. And now it just so happens in Excel that it is showing what? 6 decimal places. So after this iteration here, there's no changes, at least not in the first 6 decimal places. And here, because we're looking for an x-intercept, we know that the value, once we actually get to this correct value, the correct intercept value, when we plug it into the function, we should get 0. So now this isn't actually 0, but the decimal places where there are non-zero values are much less than the decimal places that Excel is showing, so it's just rounding to 0. You know, we could, in these columns, actually tell Excel, if we wanted to, we could go here to increase our precision, and then we could even see more decimal places if we really wanted to. But we don't need to do that, so we'll just go back down to 6 decimal places. And if you really want to be particular, you can format things nice and neatly there. But yeah, that's it. That is the idea here. Now, there's a couple other little things that I can show you right now, and that would essentially be what happens if we change things. So instead of having a function such as x squared minus 5, what if we had something that's a little bit more particular? Like what if we had the, I don't know, the sine of the natural log of 1 minus x, I don't know, something like that. Okay, then our derivatives are going to be a lot grosser, right? So our derivative here would be something like would be cosine of the natural log of 1 minus x times the derivative of the natural log, which is 1 over 1 minus x times the derivative of 1 minus x, which is -1, which I'll just put a negative in front. Okay, so you get something really gross here. You can go ahead and do something like this. You have to be careful when you're entering things in. So comments I wanted to make here would be that Excel, you can do sine. So that works, so sine. You can do natural log. That works. And sine and cosine, they default to accepting things in radians, not in degrees. So that's fine. So we can do 1 minus our x value, which is the value in B2. Close the log, close the sine. And that is giving us something a little bit weird here. Why is it doing that? So that's the one thing you got to be a little bit careful of, is when you do work with these values here, B2 is 2. So you might have to do a little troubleshooting. So what is 1 natural log of 1 minus B2? Well, that should be the natural log of -1. That's why the natural log of -1 is undefined. So in this case, our starting value that we had, we picked that for a different function. So of course, this might not necessarily be great. So let's do 5. 5. So is there any issue there? Oh, because it's negative x, right? So let's try, in this case, what if we tried negative 2? There we go, that works. That works. So the reason why that works is 1 minus negative 2 is 3. So natural log of 3 is defined. Okay, so that's working now. But what you will notice here is if you are adding in more complex functions, sometimes errors can happen. It usually has to do with domain, so you have to really think about what actually is being fed into. That's how we discovered we were actually trying to take the natural log of a negative number up. That's not going to work. That's not going to be great. So, and then here for your derivative, we can edit this, right? Our derivative in this case would be negative the cosine of the natural log of 1 minus our current value, b2. So close the log, close the cosine, multiply by 1 over 1 minus our x value. Denominator closed, last parenthesis closed. And we can drag that down. Drag that down. And you can see this has given us errors even here. Why exactly is that? Well, depending on what value you plug in, you have to know what your function looks like, because maybe you're plugging in a value where it's on the other side of a discontinuity or something. Because we're certainly going to have discontinuities in this sort of example because we've got a natural log and a sine. So there's going to be some sort of something weird going on here. If we just make it a little bit different, we can see here that it seems that these values are all getting closer to this negative 22.140693. Okay. So here we've got Desmos opened up, so we can graph f of x equals sine of the natural log of 1 minus x. And we can see here that there's some weird stuff going on. When x is 1, we get the natural log of 0, which is undefined. That's why we get this weird discontinuity kind of asymptote spike happening. And if you notice here that if we do our tangent line, so if we come up with our derivative, so f prime of x, there's our derivative. So if we do the equation of our tangent line, let's make y equals f of a plus f prime of a times x minus a. We add a slider for a, we can see our tangent line moves around a little bit. We had an issue with negative 2. And if I do negative 2, why was negative 2 an issue for our Excel document? Well, do you notice here where this line intercepts the x-axis is over here? And that means we would have to then try to plug in this x value into our red function. But do you see how that x value is no longer in the domain of our red function? So sometimes an x value you plug in isn't necessarily going to lead to an intercept. In this case, the tangent line, its intercept is outside of the domain of our function. So negative 2 is just not a good value. Now we could move it closer, and now you see it is going to intercept at values that are now in the domain of our function, which is good. So what we can do here is let's actually look at the value we plugged in, which was negative 5. So negative 5, so right here is our intercept. And if we look all the way over here, it's going to go to this value between negative 32 and negative 31.5. And ultimately, it predicted for us a negative 22 value for the intercept of the red line. And we can see right about there, negative 22. So that -5 did produce a value for us because it just so happened that it did not, the intercept of the tangent line didn't dip into an area that was no longer part of the domain of the original function. So just be aware of that. Your choice of initial value can lead to issues, especially if your function has discontinuities or asymptotes, or has a domain that is less than all real numbers. For things like polynomials, x squared minus 5, you shouldn't run into any issues